Assalamu alaikum and hello everyone. I hope you took the time to practice exercises 2 and 3 on your own. In this video, we are going to jump to exercise 4 together. Let's read the problem. We have a map defined from R3 to R3. Just like before, we will show it is linear, find its kernel and its image, and check if it is bijective. Let's begin. First, we must show that f is linear. Let x and y be two vectors. First, we are going to show that f preserves addition. For this, we calculate f of x plus y, which is f of x1 plus x2, y1 plus y2, and z1 plus z2. Now we apply the rule of our function. Next, we separate the terms. And here we find that it is f of x plus f of y. Let's do this for scalar multiplication. We are going to calculate the image of our first vector multiplied by the scalar. We return to see how is our function. I am going to take this, then plug it here. I must add a here, a here, a here, to a, and to a. Okay, we factor out the scalar a, and we get this, which is a multiplied by the image of x. And we perfectly recover our definition of a linear map. Then we can conclude that f is linear. For question number 2, let's find the kernel of f. We are looking for all vector x, y, z that map to the 0 vector. This gives us a system of 3 equations. Let's solve it. From equation number 1, we get x equals to minus 2z. We plug it in the third equation. We get minus 4z plus 2z equals to 0. Then z equals to 0. And from the second equation, by substituting back z, we get also y equals to 0. And by replacing z here, we have also x equal to 0. So the only vector in the kernel of f is the 0 vector. Then the dimension of the kernel of f is equal to 0. Now let's find the image of f. We write out the general form of the output and separate the variables x, y, and z. This means the image is generated by 3 vectors. Let's call them u1, u2, and u3. And we can write the image of f is generated by u1, u2, and u3. To see if they form a basis, we must check if they are linearly independent. We take 3 scalars a, b, and c and set their linear combination to 0. This gives us another system of equations. If we subtract equation number 1 from equation number 3, we obtain to a equals 0, then a equals 0. If we plug this in our first equation, we get c equals to 0. And from equation number 2, b is also 0. Therefore, the vectors are linearly independent and form a basis. Since there are 3 vectors in the basis, the dimension of the image is 3. Our final question is F bijective. To be bijective, a map must be both injective and surjective. We already have the kernel of F equals to the set containing the 0 vector. So F is injective. Furthermore, because the dimension of the image is 3, which is exactly the dimension of our arrival space R3, the map is surjective. We can write it like this. Since it satisfies both conditions, F is indeed a bijective map. And that concludes exercise number 4. Excellent work today. Keep practicing, and I will see you in our next video.